Yo, 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 how's it going, guys? We're doing Exponential Equations Classwork. Let's get going. So 2 to the 3k equals 64. Remember, that goal is to use the sheet that has every single power I expect you to know. And you can just, again, keep it in your notes. But 64 is one of those powers. You kind of just have to memorize that that is 2 to the power of 6 on that list. I mean, you don't have to memorize it. You have the list in front of you. If you would like to be really good at these, you do have to memorize them. Anyway, 64 is the same thing as 2 to the 6th. And now that we have both of these bases being exactly the same, we got 3k is equal to 6, divide both sides by 3. All right, k is equal to 2. Easy enough. All right, number 2. This one tricks people up because they don't know what to do, but they forget that anything to the 0 power is 1. So we may rewrite this as negative v is equal to 5 to the 0. Or in other words, negative v equals 0, or just v equals 0. Easy peasy. Continuing on. Here we go, number 3. So this one is already set up nice and neat for us. We already have those like bases. This is quote unquote super easy in terms of not having to change anything. But again, it could be something that tricks people up because they forget what to do when there's not that extra number. We want to add 3a to both sides here. 6a equals, now this is 0. So we divide by 6 on both sides, and we get a is equal to 0. So one thing to note is if you could notice, like here or even at the top, you could have just said, hey, I know it's got to be 0 because if you plug in 0, they're the same on both sides. There are some equations that are called trivial, and number 2 and 3 would be considered trivial enough that if you just didn't write any work and wrote just the answer, I would give you full credit for your test for sure. All right, number 4. Number 4 is, again, it's set up in the easy way, but I picked a question on purpose that could be tricky because when you do, you're adding 3r to both sides, which is the most natural way to start solving. You end up with negative 2 is equal to 0. You have to remember that means no solution to the question. If you get a false statement at an end of the problem with no variable, no solution at the end. All right, continuing on, number 5. Now we're getting into the point where things are slightly more difficult. We have to deal with the 16 and the 64. There are actually 2 ways to solve this problem, using 2 as the base or 4 as the base. I'm going to pick 4 only because I already did 2 up there. So 16 is the same thing as 4 squared, negative n minus 2. And this is going to be the same as 4 cubed to the 3n. So you got to pick those like bases, distribute the 2 to both. 4 to the negative 2n minus 4. And then 3 times 3 is 9n. We finally are like the earlier questions where they have the same base, and we can just go ahead and set them equal to each other. So negative 2n minus 4 equals 9n. Add 2n to both sides. Negative 4 is equal to 11n. Divide by 11. There we go. We get this weird negative 4 over 11 answer for our value of n. All right, number 6, continuing on here. So another rule, just kind of have that memorized. If you have a 1 over 5 or a 1 over anything, it's the same thing as a negative 1 as the exponent. So negative n minus 2, and 25, same thing as 5 squared. 2n minus 2. Distribute that negative 1. So we got positive n plus 2. And then we got 5 to the 4n minus 4, and therefore n plus 2 is 4n minus 4. Switcheroo, if you forgot the switcheroo, you're just moving everything to all the numbers to one side, all the constants to one side, all the variables to the other. So I'm going to write this as 4 plus 2, so I'm taking that negative 4, moving it to the left, and taking that 4n, taking that n, subtracting n on the other side, and we'll get 6 is equal to 3n. Divide both sides by 3. I'm out of room, so I'm not going to write the work, but you get 2 when you divide both sides by 3. Starting with number 7, we have to start using our exponent rules. So our exponent rules say that when we multiply like terms, you add the exponent. So I'm doing negative 2x plus x. That's negative 1x. 2 to the negative 1x. Minus 1. You technically don't need that negative 1, don't forget. And then the right-hand side, 2 to the 0. Anything to the 0 power is 1, and therefore negative 1x is equal to 0. Negative 1x minus 1, is equal to 0. And add 1 to both sides, so negative 1x is equal to 1. Divide both sides by negative 1, and you get -1. Number 8. So again, exponent rules, got to remember you're subtracting. So you're doing here, you're doing m plus 3 minus -3m minus 2, and you're doing 2 to that power. So you're taking this exponent on the top and you're subtracting the one on the bottom. I remembered to put parentheses because you got to distribute that negative sign, so be sure you're careful about that. And on the right hand side here, we're rewriting that 1 over 64 as 1 over 2 to the power of 6, that same exact 64 from earlier. So after that, 2 to the 4m, a negative of a negative is a positive, so I'm adding 3. 3 plus 2 is 5, and another rule, that same exact one that we used over here with this 1/5, getting that -1 there. This guy is 2 to the -6 power. I'm going to focus my camera. I just saw it blur out for a second. Okay. We got 4m plus 5 is equal to -6. So 4m is equal to -11, and m is equal to -11 over 4. I subtracted 5 on both sides and divided both sides by 4. I apologize for not showing work. I momentarily forgot, and it's too late. We're on the next page. Can't go back. Sorry. All right. Number 9, yet again, another question that you could use with 2s or with 4s, but 4s are bigger the number, actually the easier in terms of the exponents, because the exponents will be smaller. So we're going to take this 64, just like in the previous question, we're going to write it with a negative. So this is where you could start skipping steps, because you don't want to show too much work. You want to be as lazy as possible. So 2 to the -6, negative b minus 2 times, actually I just told you I was going to use 4s, and I started using 2s. Oh well. 2 to the -2, 2b equals 2 to the 4th. Again, you could have used 4s, then it would have been 4 to the -3rd, 4 to the -1, 4 to the 2. Same overall result. So 2 to -6 is distributing to both here. So we got 6b, and that's a -2, so plus 12. Multiplied by 2 to the -4b is equal to 2 to the 4th. You're still adding like terms here. 6 minus 4 is 2. Don't forget your 12 there. 2 to the 4th. So 2b plus 12 equals 4. Subtract 12 on both sides. You get 2b. Oops, I actually remembered. You get 2b, -8. And if 2b is -8, divide both sides by 2, and you get -4 as your final answer. On to number 10, same exact concept. 36 is on that list of numbers to memorize. It's the same thing as 6 squared with a p. And then again, a 6 squared with a 3p minus 3. And this one is 6 to the 3rd power. So you get 6 to the 2p times 6 to the 6p minus 6 is 6 to the 3rd. You're adding like terms. You get 6 to the 8p minus 6 is 6 to the 3rd. 8p minus 6 equals 3. Add 6 to both sides. 8p is equal to 9. Couldn't even see my work. I apologize. Divide both sides by 8. And you're done. P is equal to 9 divided by 8. And then on to number 11. Exactly the same base of 6. Let's continue doing it. 6 to the n times 6 squared equals 6 to the -2n. So 6 to the n plus 2, adding those like terms when you add your exponents. N plus 2 is equal to -2n. Subtracting n over here on to both sides of the equation, you get 2 is equal to -3n. And divide both sides by -3. You get -2/3 is equal to n. All right, now we're getting into these questions that start looking real nasty. This one, got to use 2s. Can't use a 4 because 32 doesn't work with the 4. So got to deal with that 2 instead. So this is 2 to the 4th. So the -3x multiplied by 2 to the -4, because it's that 1 over 16, -3x minus 3, is equal to 2 to the 5th power to the 3 minus 3x. Lots of multiplication to do here. 2 to the -12x multiplied by 2 to the +12x plus 12 is equal to 2 to the 15 minus 6x. We got to add like terms. When you multiply like bases, add like terms. -12 and 12 cancel, so you just get 2 to the 12th. is equal to 2 to the 15 minus 6x. 12 is equal to 15 minus 6x. Add 6 to both sides, subtract 12 on both sides, or just actually subtract 15 both sides, probably faster. So negative 3 is equal to negative 6x. Divide both sides by that negative 6. If you decide to reduce your fraction there, you get positive a half. Beautiful. We're almost done, guys. Let's finish this up. Number 13, we have 5 squared to the negative 2x is equal to 5 to the third, and then negative 4x is 5 to the third. Negative 4x equal to 3. X is equal to 3 over negative 4. Done. Easy peasy. Last problem of the homework assignment. We got some 9s, and the 243, those are going to turn into 3s. So we got 3 squared times 3 squared to the negative r is going to be 3 to the 5th power to the 3r minus 1. 3 squared times 3 to the negative 2r is 3 to the 15r minus 5. Distributive property there, we got 3 to the 2 minus 2r is equal to 3 to the 15r minus 5. 2 minus 2r is 15r. That's an r, by the way. That's Mr. Richard's interpretation of an R. All right, and let's go ahead and add 2r to both sides and add 5 to both sides. And we're going to get 7 is equal to 17r, and therefore 7 over 17 is equal to r. Almost ran out of room there, but we're officially done. Have a wonderful rest of your day, evening, weekend, whatever it is. Peace out, guys.